Hello everyone, myself Professor Kishan GS, Assistant Professor, Department of Mechanical Engineering, Maharaja Institute of Technology, Mysore. Today I will be taking the session on pneumatic linear actuators, which is a topic in Module 4 of the subject Fluid Power System 17ME72. In this today's session, we are going to study the basic functionality of a linear actuator, different types or the classification of pneumatic linear actuators with its working principle. Okay, so basically when we go with the term called as actuator, actuator is a device that leads to the purpose of actuation. We have studied the basic functionality of linear actuators when it comes to hydraulics in the previous sessions, whereas now today we are going to study the same topic called as linear actuators under the influence of the term called as pneumatic. So what is this pneumatic? Pneumatic, whenever we go with the usage of word, it means to say the working medium is air. Since in case of fluid power system, a highly pressurized working fluid is required to perform the actions or to perform the applications which are beyond the limits of human reach. Okay, we are going to consider the highly pressurized air here, which is nothing but the compressed air in case of pneumatics. So since it is pneumatic linear actuator, it is the compressed air that leads to the linear actuation in the work output is what we are going to define with the term called as pneumatic linear actuator. So basically, how do this pneumatic linear actuator do look like? So it will be consisting of a tube, and tube will be sealed on both the ends because the tube, whatever we consider, or the cylinder should not lead to any kind of leakages that may result during the functionality or working of the actuation medium. So thereby it will be sealed on both the ends, that is a tube which will be sealed on both the ends, and it is fitted with piston and piston rod. So the moment in which the linear actuation is derived is basically due to the piston and piston rod which is housed or which is fitted within the tube, wherein it is sealed on both the sides to avoid leakages. And lastly, it produces linear motion. So the movement of piston and piston rod inside the tube will always be considered to be a reciprocatory medium or the linear motion wherein it is derived to get the particular application done. So this is something regarding pneumatic linear actuator. Pneumatic is the usage of air. Basically it is compressed air. Linear is the linear motion wherein we are going to derive, and the actuator is the component that leads to the derivation of linear motion as output due to the presence of pneumatic or the compressed air. Basically, when it comes to classification of pneumatic linear actuator, as in case of hydraulics, here also it is of two types. One is single acting cylinder, another one is double acting cylinder. So we will recall just the working principle of a single acting and double acting cylinder. See, we use the word called as cylinder when we define the system to be deriving a linear motion as the output. So when you go with the concept of linear motion as the output, okay, see, both extension and retraction should be considered in case of actuator. So here, if it is a single acting cylinder, we are going to consider only the extension part or lifting up of the load is what we target using the compressed air. So that becomes single acting cylinder. Means to say that out of both the strokes, extension and retraction, if we are targeting only extension that leads to the lifting up of the load or carrying the load, then we consider it as the single acting cylinder. So what happens in case of single acting cylinder? The retraction will be of different means. Okay, so basically that retraction will be of spring return type, gravity return type, or the diaphragm type in case of pneumatic single acting cylinder. Only extension is considered using the pressurized air or the compressed air, whereas the retraction is focused on the spring return type, gravity return type, or diaphragm type. Then comes the role of the double acting cylinder. In case of double acting cylinder, we are going to target or control both the extension and retraction of the piston that leads to lifting up of the load as well as bringing the piston to its original position. So when we target both extension and retraction, we are going to consider that cylinders as double acting cylinder. In case of double acting cylinder, we will be having 5 types. The first one being through rod cylinder, next being telescopic cylinder, next being diaphragm cylinder, impact cylinder, and basically the last one, rodless cylinder. In case of rodless cylinder, we have again 3 types, that is C-shaped housing type of rodless cylinder, magnetic type of rodless cylinder, cable type of rodless cylinder. So here the actuation medium what we are going to take, that is piston and piston rod. To what extent this piston and piston rod are being considered for both extension and retraction, we are going to categorize under 5 groups of double acting cylinders. Now let us take the single acting cylinder with its construction and working in case of pneumatic system. See, basically we have taken 3 types here: spring return type, gravity return type, and diaphragm type. Here the common observation is that we are going to concentrate only on the extension of the load. That is, if you look at the figure here, we have the load W attached on all the ends of the piston rod, whereas we are concentrating on the extension of that particular load. The retraction will be basically on these 3 categories. So if you go with the spring return type, so we have a tube or a cylinder with opening that leads to the flow in of compressed air into the system, and within that particular tube or the cylinder there is a piston and piston rod arrangement here, and for that piston rod there is the additional attachment of weight which is to be derived along the linear direction or reciprocatory direction. So this is the basic construction of a single acting cylinder, but we are targeting on the retraction part. So what we are doing is we are going to have the assistance of a compressible spring on the piston rod end, which is in contact with the tube or the cylinder body, such that once the compressed air enter through the inlet or the port into the cylinder, that leads to the movement of piston along the linear direction from left to right, such that it carries the load W. Once it carries the load, the supply through the port or through the inlet, whatever opening we have here in the cylinder, that supply of compressed air will be cut off. Once it is cut off, in order to bring back the piston to its original position as it was at the start, this compressed spring will expand and bring the piston to its original position. So thereby the retraction is controlled by the spring which is present inside the housing at the piston rod end. Next comes the gravity return type. So the gravity return type is a type wherein instead of the presence of the spring for the retraction, the cylinder arrangement or the tube arrangement is kept upright in its position, so that the extension of load is along the upward direction, whereas retraction is taking place due to the gravitational force. Observe the figure carefully here. This is a tube which is fitted with piston and piston rod, and to the piston rod we have the additional weight called as W, and this load will be carried once there is a supply of compressed air through the port provided at the bottom of the cylinder, such that it results in the exertion of pressure onto the piston, so that the piston move along the upward direction, that leads to the lifting up of load along the upward direction. Once the load is being lifted, now to bring back the piston to its original condition, you are going to stop the cutoff, stop the supply into the port here, such that whatever compressed air which was inside the cylinder that has resulted in the extension will come out of the same port due to the gravitational force which is being observed onto the piston and the piston rod. Since it retracts back basically on the gravitational force, this type of cylinder is called as gravity return type of pneumatic linear actuator belonging to single acting category. Here remember one thing, whatever may be the condition, the supply of fluid medium is compressed air. Okay. Moving on with the third type for the single acting cylinder, it is the diaphragm cylinder. So here the extension of diaphragm or the extension of the piston rod is not with respect to piston and the piston rod. Instead, it is the diaphragm which is attached with the rod, and that rod is in contact with the additional weight which is to be drawn or which is to be driven along the linear direction. The major benefit of using the diaphragm rather than the piston is that for a very small stroke, the diaphragm has the capacity of producing or multiplying maximum forces. So hence what happens? So beyond the applications wherein piston is being considered for extension of the piston rod or the rod, which results in the movement of load at a very faster rate, instead of piston rod arrangement, the diaphragm rod arrangement is preferred. So this is what the diaphragm cylinder type of single acting pneumatic linear actuator goes. So here again there will be an opening provided for the compressed air to enter into the cylinder. So inside the cylinder will be having a diaphragm. It will be a tube like structure that revolves around the system for multiplication of forces. So whatever the compressed air that has resulted in the entry into the cylinder, that compressed air will be applied or fed onto the diaphragm, and that diaphragm results in the multiplication factor of forces which it has received, so that it moves the piston rod along one particular direction or in the extension direction, wherein the load, external load W, is to be extended or moved. So thereby what happens, the compressed air resulted in the movement of the additional load along the direction through the assistance of diaphragm. But this is a single acting cylinder. We do has the capacity of concentrating on the extension part, whereas when it comes to the retraction part, we will always have the assistance of spring on the other side of the diaphragm, so that after extension the supply from the inlet or the port into the actuator will be cut off, and thereby the retraction of the diaphragm to its original position will always be taken care by the spring which has compressed during the extension. So this is about single acting cylinder. Now let us study the concept of double acting cylinder. As we know, double acting cylinder focuses on controlling the extension and retraction forces of piston through the supply of compressed air. So we have different categories of double acting cylinders to be studied here. The first one being through rod type of double acting actuator. So here in this particular construction, the piston will be consisting of the piston rod on both of its side, so that if you take the extension to be from left to right and if you take the retraction to be from right to left, the force applied on the piston for extension and retraction will be same, because the area wherein which the compressed air that could be subjected onto the piston end, that leads to extension or the retraction remains same. So hence the extension and retraction forces will be exactly same, and this will also be considered as a coupled double acting cylinder, wherein the dual application could be considered in its use. Next comes the use of telescopic cylinder. So telescopic cylinder is a type of double acting cylinder whereas the sequence of movement in the linear actuation is necessary to perform the particular work at different stages, whereas here in this particular case, if you observe, so if this is the entire tube which consists of number of linear movement or the linear actuating modes or the pistons here or the piston rod here, so that leads to the movement of one after the other. The first tab opens, next comes the second tube as such. So the sequence of opening for a particular extension will be controlled by the compressed air here, as well as the retraction of the same will also be taken care by the compressed air. Hence it becomes the telescopic type of cylinder. So again here both extension and retraction will be from the same particular control of compressed gas. Next comes the diaphragm cylinder. So we have taken the graphical symbol for diaphragm cylinder here, but to go with its construction and working, the diaphragm cylinder construction remains same as that of the single acting cylinder, but the only fact is that instead of the spring that would be leading to the retraction as in case of single acting cylinder, so here what happens, it is the secondary opening that leads to the retraction of diaphragm. So keep one thing in mind, the construction remains same, but instead of the spring we will be having one more port works for the retraction of the diaphragm in case of double acting cylinder. Next comes one of the major impact cylinder. So here what happens, inside the cylinder tube the piston will be given with a support structure for the retraction phase, not for the extension, because once there is extension of piston, that leads to the movement of the load along the linear direction. During the retraction, the compressed air, whatever it is being fed onto the piston rod end, that may lead to the damage of piston end once it can reach to the original condition. So there may be even a chance that the retraction force may also result in the movement of piston and hitting the piston onto the cylinder wall. In order to avoid that, there will be extra projections given in the cylinder body such that the retraction forces is controlled before it is reaching the initial condition or before it is reaching the wall and getting damaged due to the retraction. So this is called as impact cylinder. So there will be external projection given inside the cylinder so that the piston will be held without leading it to hit into the wall of the cylinder. So this is about impact cylinder, through rod cylinder, telescopic cylinder and diaphragm cylinder. Now let us study something on rodless cylinder. As the name itself suggests, rodless cylinder, it means to say that the housing consists of a piston, but the piston will not be supported by anything called as rod, wherein that leads to the extension or retraction of the external load. The extension and retraction of the load is directly be considered by the compressed air here, because since it belongs to the double acting cylinder category, both extension and retraction will be controlled by the compressed air, whereas the extension and retraction of the load, what it is to be derived or what it is to be targeted, that will not be helped through the piston rod here. Instead, we do have the specific assembly called as carriage. So if you observe in these construction, there is an external body projected onto the cylinder housing. That means to say there is a carriage. The movement of piston leads to the movement of carriage, or the movement of piston carries the carriage along with it, that leads to the extension or the retraction of the load as per the defined task. So the first one being C-shaped housing type of rodless cylinder. So if you observe the casing here, the cylinder will be made out of almost circular in its nature, but at the end there will be a cut portion wherein the carriage assembly is being fixed onto it. Means to say that the housing will be of C, the capital letter C in its shape, and it consists of a carriage assembly. So here, if you observe carefully, we have a rodless piston written, which is in line with the carriage. Means to say that the piston is housed inside the body of a tube or a cylinder, wherein onto the sides or the end of the piston there will be a connectivity at the projected part, that is nothing but the carriage assembly onto the cylinder tube. So means to say that the movement of piston leads to the movement of carriage along the same direction, such that to whatever the way the external load is being attached, that motion will be derived. Say for example, if you have this particular arrangement here, if you feed the compressed air from left portion of the cylinder, okay, thereby what happens, the compressed air tend to move the rodless piston from leftmost part to the rightmost part. Means to say that there is extension or linear movement of piston which is taking place, wherein the compressed air is being the flow medium. So when there is a linear movement of piston from left to right, the external load is being attached to the carriage, and since the piston is rodless piston, the linear movement of piston leads to the carriage that is in contact with the piston, and even that carriage will move along the linear direction, getting the external work done. So this is about C-shaped housing type of rodless cylinder or rodless double acting cylinder. Next comes magnetic type of rodless cylinder. Here what happens, the rodless cylinder or the rodless piston, okay, whatever we are going to concentrate here, that piston will be made out of magnetic material, and the carriage assembly is suitably selected such that the piston which consists of magnet in it, the movement of piston moves carriage assembly along the same direction. So if you observe the figure here, so this is the piston which is housed inside the cylinder, and this is the carriage, and this is the magnetic tape that leads to the movement of carriage along with the movement of piston. So thereby what happens here, if there is a supply from one of the end of the cylinder opening, so that the rodless piston move from leftmost pass to the rightmost part, due to the presence of magnet here, the same piston, while its movement along the linear path from left to the right, moves the carriage assembly from left to the right because of the magnetic pull, and thereby when it has to be retracted, the supply from the other end of the cylinder for the rodless cylinder leads to the movement of rodless cylinder from right to the left, thereby the carriage assembly moves along the same path due to the magnetic pull. So since the piston consists of magnet here, the carriage assembly which houses the external load, okay, and since it is magnetically attracted, so the movement of piston with magnet leads to the movement of carriage assembly, and this is one type of magnetic type of rodless double acting cylinder. Next comes the last type, cable type of rodless cylinder. So as the name itself suggests, it is the cable that connects the piston with the pulley arrangement on either side. So observe here, we have two pulleys and we have a fastened thread which is in contact with the piston on its either side. On both the sides of the piston, there is a fastened thread which is in line with the connection to the pulley, and that particular cable itself is the reason for extension or retraction of the external load. Here we do have the external link onto the cable, means to say that the load which is to be driven will be fixed onto the external link here, such that the linear movement of cable will result in the linear movement of the external load which is attached to the link here. So observe carefully, there is a piston, there is a fastened thread on either side of the piston which is in connection with the pulleys which are present 2 in number, wherein the same fastened thread is having an attachment called as link that leads to the attachment for the external load. So once there is a supply from the supply onto the piston end from the compressed air, so thereby what happens, the piston tend to move along the other direction based on the direction of compressed air feeding onto it. Say for example, if this is the port that is feeding the compressed air onto the piston, then piston try to move towards its right side. So when you try to move towards its right side, what happens? The fastened cable onto the piston which is in contact with the pulley try to rotate the pulley along anti-clockwise direction, such that the link moves along the anti-clockwise direction or along the direction in which the cable is being pushed now. And thereby, if for the retraction, if there is a supply of compressed air onto the other side of the piston, then the piston moves from right to the left. Thereby what happens? It pulls the thread onto its right side towards it, and it pushes the thread onto its left side, so that the link is moved from left side to the right side, that is in terms of the clockwise direction, such that the retraction is being achieved. So this extension and retraction of the external load is basically due to the connectivity called as link, and the movement of link is basically onto the force that is exerted on the pulley by the piston through the fastened thread that results in clockwise and anti-clockwise movement of the pulley. This is something called as cable type of rodless cylinder. Here we don't find anything called as piston rod. Instead we have the attachment that leads to the movement of the external load in the absence of piston rod. So this is about the pneumatic linear actuators of single acting type and double acting type. Thank you.